Alright, so today we're starting chapter 4, which is, we're now going to look at, we're still looking at the scatter plot, but we're now going to look at that regression line, which is the straight line that, that gets placed into that scatter plot. So the calculator works it out for us, that regression line generally. So we've got our scatter plot, so I'm just going through what we're up to. So we really need to make sure we know that which one's the response and which is the explanatory, because the response goes on the Y and the explanatory goes on the X. Okay, so the calculator will do most of this for us, but it fits what they call the regression line. So it puts, it's like a line of best fit in here. So what it's called is called the least squares regression line. So why is it called the least squares regression line? It's because it's how it is making it, how it calculates it. And what it does when it is calculating it is it takes into account all the residuals. And the residuals are these little distances of what the actual thing was and what the line is. So it balances it all through and it thinks of all these little residuals and things like that. So you have to be careful that you can only, there's a few assumptions that when we're using it. So when we go to put this least squares line into our scatter plot, we're assuming that the data is linear, and that's really important. You'll see in the questions, they'll say, what assumption have you made? And you have assumed that this pattern, the scatters, the dots, are following a straight line, or so you've assumed it's linear. And there are no clear outliers. So it's not really good to have this line of best fit if you have an outlier, because an outlier drags the line out of its best position, okay? So they will say that's what you've done. You've assumed when you're using one of these that it's linear and that there's no outliers. So as I said, you do need to know about these residuals. So the residual is like the vertical distance, so that's what I'm telling you, between the data point. Now, sometimes the data, when it says data point, I like to call it the actual. So actually what happened. You know, say when we did height and weight, your weight was actually this. Now, also, it might help when it says the vertical distance. So maybe just write the difference in Y values. So that's what you're actually looking at, yeah? So if we were doing like the example of weight and height, we would see what this residual up here. We'd see what that person weight they actually had, and then we would look at the predicted what the line predicted its weight to be, or that person. So it's the vertical distance between the data point and the regression line. So you might want to write for that bit what the line predicts. Yeah? Predicts for Y. I just think that will help you. I've noticed like kids are getting that will be more clear of what you're doing. So right down here we've got the formula. That residual value is the data value. So another thing I would like you to write in here, where can you find the data value? So the data value could be the dot on the scatter plot. So just so you're aware, or it could be found in the table of values. Yeah, so they might have given you the two lists and you might be looking for the actual value, or they may just have given it to you. Yeah, you may have just got it given. They'll say the actual value was. And now let's look where we get the predicted value. We can either read off the value on the line in the scatter plot. So that's one way. So say up here, I went and I read off what that one was for. So you're always talking about, say we were talking about the person that had 1.6 meters high. So we go up there and we go, right, they predicted a weight of whatever, and there was here, that's their predicted weight. And up here in the actual dot, that was their actual, yeah? So their actual Y, and then their predicted Y. So, yeah, so where can we get the predicted? We can read the value off the scatter plot, or the other way is we'll use the equation of the line to find the Y. So what I mean by that, this least squares regression line, because it's a straight line, and we've talked about this, it'll have this pattern, the A plus BX. So we will be able to use that formula to maybe find our predicted Y. Okay, so you use that equation to find our predicted Y. All right, so just here, down here, there's a little warning, and I've said that before, you need to be really careful that you've picked the right EV and RV before we go off on doing all the other questions with the least squares regression line. All right. So we've said the least squares regression line, it is a straight line, and its basic formula is this, the Y equals A plus BX. So we're going to know that A is, and you might going to jot this down, that's the Y intercept, yeah, on the graph. And what we're used to seeing B is normally, B for us is normally being M. So you just might have to write that this is the gradient or the slope, okay? And obviously the Y is RV and the X is EV. So that's what will change when we do them. So you can put them into your calculator, remember where we got the R value and all the A and B were there, or you can use these equations to find the B value and the A value. So you need to just have a little look here, and you can see you find the B. So we might write this here like this as well, that B equals the R value times, now SY means standard deviation, and when they say the Y, but if we were talking about our scenario, we'll say the standard deviation of the RV list, yeah, over, and it'll be the standard deviation of the deviation of the EV list, okay? So you'll see it, you get these questions and all of a sudden you don't have the list, but they've given you the standard deviation of one of the variables and the other one. That means we could work out this B value using that. Now, take note with the A formula down here, you need to have B. So you've got to calculate the B first, and then you should you can then find A using this formula. So you can see it has the Y with the line across it. What that means is the mean of the RV list, yeah, that's what that Y is, minus B times the mean of the EV list, okay? So they'll probably give that out in words in the scenario. So it doesn't sort of stand out to you exactly like this, but these are the rules you can use. So down here we've written a little bit, you might write that. So you might say that this is, just remember the standard deviation, X is EV, Y is RV, all right? Okay, so let's get into it. Okay, so this one's practicing using those formulas. The heights, and it's mixed. The heights and weights of 11 people have been recorded, and the values of the following statistics have been determined. So, this should be the mean. There should be a little line above that. So you can see they've given you, we called it X and Y. What they would have normally said, they would have said the mean weight of this group is the mean height of this group is 173. That's how it would have been worded out. All right, so we want to go find the formulas. So what we'd do is we'd write the formula and then we substitute in. So they've told me what R is. 8502 times standard deviation of Y, which was 7.5943, over the standard deviation of X, which was 7.443, and we'll get a value. Okay, so I've done the B value. Now you can find the A value, which is the mean minus the B times, the mean of X. Okay, so in this instance, it was 65.4545 minus B, 0.87 times the mean, 73.2727, and we're going to get a value. Okay, so now we've got this, we could write out the least squares line. So we know that there would have been some scatter plot, and it was height versus weight, so weight and height, and they've found this line of best fit in here. So we're going to write out this formula, and when you're asked to write it, you've got to make sure you use the variable names. So I'd be writing for this one here, I would say that we could predict, use the least squares line. This is what it's going to be. We're going to say weight, and the weight was in kilograms, I believe. So I'll write kg equals. Now, this is where we write the A value first. So A, which was negative 85.29. Then we write the B value. The B values are positive, so 0.87. And we're going to times it by our EV, which was height in centimetres. So there I've written out the least squares regression line, okay? So here was the B value, here was the A value, that was RV, and that was EV. So I could use this to get a prediction on someone's weight according to their height. Just boys, to take note too, this intercept, the y-intercept is when the x is 0. So only if it says 0 here would you read off the line, and say that is the A value. Okay, so be really careful. It has to be, x has to be 0. Often in these graphs, it's not 0 down there because it's irrelevant that early on. So they're just showing you the relevance. So be really careful. We'll see it in some questions and I'll go through it. All right, so here's practicing with the formulas, and this is how I'm to show you how it won't, it'll come out in the exam. So the statistical analysis of a set of bivariate data involving X and Y resulted in the table below. So here they've given all this, and they've actually even given you the least squares regression line there. So I know that this is A and this is B. It says using this information, the value of the correlation coefficient is 4. So if you remember, in our B formula had the correlation coefficient because it was R times SY over SX. So in this scenario, I can find, this is the question, so I must have everything else, and I do, because I can read off here that there's the B value. So 1.31 equals R times SY, 3.24, over SX, 2.33. And what could I do now in my calc? Yeah, I'll just go solve and comma R, and I'll get that answer. Okay, so we got D, 0.94. Okay, I've gone and found another one for you. So in this next question it says, a study was conducted investigating the effects of drinking coffee on sleep. So the amount of sleep in hours and amount of coffee, so there's two numerical there, were given. The following statistics were shown. So up here they're telling you how what the RV was, because they've conducted to investigate the effect of drinking coffee on sleep. So the amount of sleep is what the RV is. So effect on sleep. So sleep hours is the RV. That's what we're looking at. And we're seeing if you add more coffee to it, well, how does it change? So coffee is EV. So what I would probably go down here, once I've worked that out, that sleep is given. So here, on average, an additional coffee cup. So what you need to do is maybe put that this is the Y values and this is the X values. So right here is the mean of Y and the mean of X. And this is the standard deviation of Y and standard deviation of X, and there's R. So when they write on average, that is a word used for the B value. So write that up, that's a B value. When they say on average, for each additional cup of coffee, the amount of sleep, so they're just asking you pretty much to find the B value. So you've got the formula, which would be this, and then off you go. So I guess the trap here, so this was probably done the following year. They would have done that one above first. The trap here was that the Y was listed first and then the X. Not very common for that to happen, but they've done that to make sure that you are checking. So R times SY over SX, 1.56, and let's see what our value will be. So we get the answer to be A, okay? So negative 0.55. All right, the least squares line of the form y equals a plus is fitted to a set of bivariate data. Here they've given you the information. The slope, so what's the slope? That's another word for what value, boys? B, good, B value. So you've seen up here, you've got the mean and all that. So we must be using this formula. And off we go. So we can see they would have given us everything, didn't they? What did they say? No, they want me to find B, but I haven't been given R. So now I've looked at A, and if we look at our A formula, it is X mean. Have we got everything of this? I think we do. We've got the mean of Y. Yes. We've got the mean of X. Yes. And we've got the A value. Yes. So what's the only thing missing? Because that's times. The only thing missing is B. So we can do the solve. So I'm going to go 3.1 equals 5.60 minus B times, did I do that wrong? No, 5.5, they're very close. And now I can do solve. So that one was where we used A because it had the missing thing. So we got B to be our answer. Okay, now let's do the last one. The least squares line used to model average temperature and latitude was recorded at 7 different weather stations. Here's the least squares regression line. When the numbers in the least regression line are rounded to 3 significant figures. So here's a practice of significant figures. So remember, you start counting when you have non-zero numbers. So for this one, I'm already counting. 1, 2, 3. So I've looked at 3. Now remember, you've got to look at the fourth one to see if it should be rounded up. And it should be. So the 9 has to go up. It goes up, which makes a 3 like that. Can everyone see? That becomes now 3 significant figures. For this next number, we don't start counting till we get a non-zero. So it'd be 1, 2, 3. I look at the fourth one. It's under 5, so it'll stay at 0.877. So you're looking for this written out, but with those numbers. And where is it? It's E, is it? E. Okay, in a study of associated person's height in centimetres and body surface area in square metres, the following least squares line was obtained. Which of the following is a conclusion that can be made from the least squares line? An increase of 1 metre body surface area is associated with an increase. When they say this increase, they're talking about the gradient. But are they increasing the gradient when they say increase the body surface area? They're not, are they? Because body surface is y. So this is definitely no. An increase of 1 centimetre in height, that sounds good, is associated with an increase of 0.9. That's true because that's the gradient. If I times that number by 1, it will go up by 0.019, won't it? If I times this by 1, yeah, it increases the formula by that much. So this one sounds good. This is not true. That's not the R value in there. And a person's body surface area in square metres can be determined by adding. That's a very gross statement anyway, so I'd get rid of that. And a person's in height, we can't say their height can be determined. This is just a trend. So that's out. I'm definitely happy with that thing.